We are going to go over the free fall problem first. So in the first question, you're asked to figure out how fast is Superman traveling when he hit the ground, 8.13 seconds after falling. How fast means that you're trying to find a velocity. We're going to use this equation VF is equal to VI plus A, your acceleration times the time. In this problem, your initial velocity or speed is 0. Acceleration is just negative 9.8 meters per second squared. Acceleration due to gravity multiplied by your time, 8.13 seconds. So you get negative 79.67 meters per second as your answer. Second question, how tall is the Eiffel Tower? You're trying to figure out distance. So the distance equation is 1/2 times A times t squared. Again, acceleration is just negative 9.8 meters per second squared, and then multiplied by your time, the 8.13 seconds squared. So for that question, you get negative 647.7 meters as your answer. Next, we're going to look at a graphing question, and we're going to look at how to do a speed versus time graph and position versus time. Since they give you speed in this problem, they give you 3 meters per second, you're told you come to a stop, and then you're given another speed of 2 meters per second. It's actually easiest to do the speed versus time graph first. So we're going to start there. So we're told that for the first 3 seconds, I have time here on the x-axis. You can see it there. So at 3 seconds, or for the first 3 seconds, we're going at a speed of 3. So that's a straight line horizontally. Then you're told that you come to a stop for 2 seconds. So stopped means speed is 0. So from 3 seconds to 5 seconds, we have a flat line just right at a speed of 0. And then lastly, we're told that for the last 5 seconds, you walk at a speed of 2 meters per second. So from 5 seconds all the way to 10 seconds, go back to 2 meters per second, and it's a flat line like that. At this point, it's easy now to go to the position versus time graph, because what you have to do to figure out distance traveled is just figure out the area of each little box here. So for our first box, we have 3 multiplied by 3. 3 times 3, that gives you 9. So what that means then is that in the first 3 seconds, they have gone 9 meters. So we're going to mark that on our position versus time graph. So we'll put a point here to represent that we've gone 9 meters in the first 3 seconds. We can connect the dots from 0. Then you're told you come to a stop. So if you're stopped, you're just waiting right at that same point. So from 3 to 5 seconds, just a flat line there. And then lastly, we can figure out the area of this box. And so we have 2 multiplied by 5, that gives you 10. And so that means that you've traveled 10 more meters. So 9 plus 10 gives you 19. So at 10 seconds, we've gone up to 19 meters. And we can connect those two. Next question, we have momentum. You're going to use the momentum equation. P is equal to m times v. P is momentum, m is mass, and v is velocity. In this problem, you're given mass. Remember, mass is measured in kilograms. And then multiplied by your velocity. On this, or in this problem, we have to pay attention to the direction for velocity. You're told that velocity, or the person is traveling, or car is traveling to the left. That means the velocity is negative. So you have multiplied by negative 24 meters per second. So that will give you a negative value for momentum. So negative 480,000. And then units, you just have your units from your problem. We took kilograms and then multiplied it by meters per second. Next question is with Newton's third law. So if the action force is the ball pushes down on the ground, the reaction force is the ground pushes up on the ball. The second part of this question related to Newton's third law is understanding the action and reaction forces. So circle the true statement below. Action and reaction forces do cancel because they act on the same object. That's not true. They act on different objects. Second one, they do cancel because they are the same strength in opposite directions. Not true. Third one, action and reaction forces do not cancel because they act on different objects. That one is true, so we'll circle that one. And then action and reaction forces are always the same size, so this last one isn't right either. The last one, conservation of momentum. So for this one, we always draw a picture first. So we're drawing our before picture. Two football players are running towards each other. So the before picture, you should see player A going towards player B. Our after picture, you're told that after the collision, one football player has a momentum of negative 10 kilograms times meters per second. And then you're asked to figure out what is the momentum of the other player. So in this problem, player A has a momentum of 250, player B has a momentum of negative 280, and the concept here is that momentum before has to equal the momentum after the collision. That's what conservation of momentum is. The other piece of information that you're told is that after the collision, one football player has a momentum of negative 10. So then the last thing we're trying to find is what is the momentum of the other player. So we're going to be solving for momentum of B, player B. And so you can see we have 250 minus 280. That gives us negative 30. So then that's equal to negative 10 plus player B. And to solve just for player B, we add 10 on both sides of the equation, and that gives us our final answer of negative 20 kilograms times meters per second.